Hello, today we're going to be looking at who does space travel best, and we'll be focusing on Star Trek. So space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. That is of course from Hitchhiker's Guide to the Galaxy. And that means if you want space travel, you've got two options in your sci-fi franchise. Make everything close together to negate the vast emptiness of space, or travel at faster than light speed, or FTL for short. And to do this, that is to reduce the time taken to get from point A to point B. So we'll be looking at which franchise does space travel best using FTL technology. So we'll be looking at the in-universe science, the real-life science and plausibility, along with the risks to determine who does it best. So today, we'll be kicking it off with Star Trek's warp drive. So get yourself some tea, Earl Grey, hot, and let's explore warp drive. The background. So Star Trek had a range of terms for FTL travel, and these include hyperdrive, lightspeed drive, and warp. And depending on the species, there's a range of methods to generate FTL speed. For example, the Federation uses deuterium, whereas the Romulans use artificial quantum singularities. So today we will only be looking at the Federation method, and we'll be assuming all terms regarding FTL travel can be used interchangeably, and we'll just be using warp for this video just to simplify things. So the 5th of April 2063 is when humanity achieved warp speed. Zefram Cochrane pilots the vessel the Phoenix and reaches warp 1, light speed, and is noticed by the Vulcans, causing first contact, kicking off Star Trek. The history of FTL travel is quite well fleshed out in Star Trek, with different races developing the technology at different paces. So the Vulcans were the first to discover warp, and were the leading experts in warp speed advancement, achieving warp 7 by 2151, and the Klingons, well, they were stuck at warp 6, and as humans, around warp 5. So the scale used to calculate warp factors changed between the original series and the Next Generation, but from the Next Generation, this formula can be used. That is, warp factor equals the 10 to the third root of the velocity over the speed of light. And that can be rearranged to calculate speeds ships travel at to be warp factor raised to the power of 10 thirds multiplied by the power of speed of light. So if warp equals 1, 1 to the 10 thirds is 1, 1 times speed of light is the speed of light. So warp has a scale of 1 to 10, and 10 is infinite velocity, which will cause the starship to enter subspace and exist everywhere at once. Statistics. So it is difficult to find concrete data for the in-universe stats. So ideally, we would know speed, acceleration, fuel consumption. So we could calculate efficiencies, distance between planets, and just have quite a lot of fun playing around with different equations. Unfortunately, I could only find this very helpful table of warp factors and speeds by Memory Alpha. So as we can see, the increases in speed as warp factors increases is not linear. So increasing from warp 5 to warp 6 isn't as impressive as increasing from warp 8 to warp 9. And that's why kind of the Enterprise D, Enterprise E, Voyager and the Defiant can all travel beyond warp 9 by a few decimal places, but all have very vastly different top speeds. So as I said before, warp 10 is infinite velocity, and that would allow you to travel anywhere instantly. So Alpha Centauri is our closest star system to Earth, and it would take us hundreds of thousands of years to get there, whereas at warp 9 it would take just over a day. And this would make space exploration feasible in the Star Trek universe. In-universe science. So every Federation ship was equipped with a warp core and could achieve warp speed. So how is this achieved? So warp engines were fueled by reacting matter and antimatter together. The fuel the Federation used was deuterium, which is our matter, and antideuterium, which is our antimatter. And these were reacted together, with this reaction being mediated through dilithium crystals. So the dilithium was essential as it didn't react with the antideuterium, which is uncommon because when matter and antimatter mix, they tend to react. So the reaction of deuterium and antideuterium produced electroplasma or warp plasma, and this provided the energy needed for ship systems. So for FTL travel, the warp plasma enters the warp field coils in the warp nacelles, and here a warp field is formed and a subspace bubble envelops the ship. Local space-time continuum is distorted and the ship achieves FTL speed. So the Star Trek, the Next Generation Technical Manual, goes into more detail. The warp fields are formed by nesting layers of warp field energy together, and each layer exerts force on the neighbouring field. As each layer is exerting a force, the total force is what causes the subspace distortion. Real-life science. So we all know FTL travel is a staple in science fiction, but is warp speed more science or is it more fiction? So we'll now look at the real-world science to see if FTL travel could become a reality and how to make it so. So we'll start by discussing the components of warp travel before exploring the physics behind it. So deuterium is a real-life material. It is an isotope of hydrogen having one neutron and one proton instead of the normal one proton and no neutrons. So deuterium is currently being researched as a fuel source and has been used in fusion experiments, generating power, so could easily be used as a fuel for a starship. So anti-deuterium is another plausible fuel source. So antimatter is matter composed of the antiparticles of corresponding particles and has the same mass but opposite charge as the ordinary particle. So matter and antimatter react together and can produce large yields of energy, so using them as a fuel source checks out. Antihydrogen has been used in experiments, and as deuterium is an isotope of hydrogen, I don't see why anti-deuterium shouldn't exist as well. So dilithium is the only component left in generating warp power, and this is fictional. And it's often used as a plot point in the show as it's a scarce resource. So in real life we haven't discovered any material that wouldn't react with antimatter, so storage of antimatter would be very difficult for us to achieve, and we don't have a substance like dilithium to mediate the reaction. So then we have a fairly plausible fuel source, but does the physics behind light speed stack up? Einstein's theory of special relativity states that speed of light travel is impossible for material objects, as any object with a mass will need infinite amounts of kinetic energy to achieve light speed. Therefore, the answer to FTL travel is it's impossible. However, there is a loophole using relativistic physics, so strap in as it's time to make my brain hurt. So the Lorentz factor is a dimensionless quantity, which simply means it doesn't have units of measurement, and it often expressed as ratios between measurements like speed and time. So this means it is possible to effectively travel at light speed and faster. So the Lorentz factor is a function of velocity. When velocity is 0, the Lorentz factor is 1, and it increases without bound as velocity tends towards c, c being the speed of light in a vacuum. The Lorentz factor is calculated simply with this equation. So 1 divided by 1 minus velocity squared divided by speed of light squared, and the entire denominator is raised to the power of a half. And this expresses how physical properties like time change when an object is moving. So now we can do some fancy maths, and as the Lorentz factor is a ratio between other measurements, we can rewrite this formula. So now we can rewrite it as 1 divided by 1 minus the ratio of velocity to speed of light squared, and that's raised to the power of a half. So when velocity is 0, beta is also 0, and the Lorentz coefficient is 1. When velocity is half the speed of light, the Lorentz coefficient would be 1 divided by 1 minus 0.5 squared raised to the power of 0.5, which equals 1.155. When velocity is 3/4 the speed of light, we get 1.512, and when velocity equals speed of light, we have 1 divided by 1 minus 1 to the power of a half, which equals 1 over 0, which tends towards infinity. So this means that as you approach light speed, the Lorentz factor is near infinite, causing a time dilation. This reduces the time experienced in completing your journey. So this has been seen on the International Space Station. So the cosmonauts Sergei Krikalev and Sergei Avdeev both experienced time dilations of about 20 milliseconds compared to that time passed on Earth, and they were only travelling at about 7,700 meters per second for 6 months. So we can use our formulas to calculate the Lorentz factor in this instance. So beta would equal 7,700 divided by c, c being 299,792,458 meters per second, and well, this gives an answer of 2.568 times 10 to the negative 5. So this gives a Lorentz factor of 1.000000000000329, which is very small, and that caused a 20 millisecond time dilation. So scale it up to much greater speeds and we can experience much greater time dilations, reaching effective FTL speeds. So there will be some links to explain this much better than I can, and in one of these links you can play about with different speeds to see how rapidly the Lorentz factor increases. So linking this back to Star Trek, the time dilation caused by the high Lorentz factor could be like distorting the space-time continuum, allowing FTL travel, and if we delve deeper into sci-fi territory, warp 10 could be when speed of light equals velocity. This gives an infinite Lorentz factor or an infinite time dilation, allowing you to travel anywhere instantly. So before we get ahead of ourselves, I would say warp drive is rooted in science. If the reaction between deuterium and antideuterium can provide enough energy to accelerate a ship close to light speed, then the ship will effectively be travelling faster than light. And as the graph shows, as you get closer to light speed, the greater the Lorentz factor, or the greater time dilation and effective speed. So if we stick to warp factor being a scale of 1 to 10, a higher warp speed could just mean travelling closer to the speed of light, with warp 10 being c. So warp drive is possible, assuming a reaction using dilithium, deuterium and antideuterium works. Risks. Any type of transport carries risks with it, and warp drive is no exception. So the big one is starships. Even civilian and scientific ships all appear to have to need to defend themselves. So warp engines tended to be quite bulky units, easy to locate in the nacelles of a ship, making them a lucrative target for pirates or Romulans or worse. So as the engines generate ridiculous large amounts of energy to accelerate the ships, if this reaction isn't contained properly, significant damage could be done to a ship or a person. So warp core breaches have been shown to destroy a ship. So deuterium is a difficult fuel to refine and process and can burn extremely hot when ignited, so it can do considerable harm again to a ship or a person, although this is a risk similar to one we all face with our own vehicles. So a rare risk is that you could run out of fuel in deep space. The Federation minimized this risk by constructing buzzard ramscopes in the nacelles to collect hydrogen and other interstellar particles to replenish the fuel as they explore deep space. So dilithium is the other critical resource, and unfortunately this is a rare mineral, found in only a few planets, making it a rare commodity that cannot be synthesized. So dilithium also broke down when the deuterium and antideuterium reacted together, meaning each ship had a finite supply of an essential resource that would need to be stored and replenished. So it does appear that Starfleet were aware of the dilithium risks, as by the 2360s they had a method to synthesize dilithium using recrystallization. So this essentially reformed reused dilithium to be used again. So this would only limit the demand for dilithium, not increase supply, so there's still a risk of using a non-renewable resource to power space travel, and space travel all areas of Federation life depends on. So that's warp drive, a well thought out method to allow Star Trek ships to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before. So the world building behind it, it's logical, with different advancements being made at different times, and it's got its limits, with warp factor 10 being absolute. So you can clearly know which vessel is faster. So although it is probably an impossibility to achieve on Earth due to antimatter being rare and extremely difficult to store, if we do discover a fuel source capable of producing enough energy to accelerate the vessel close to light speed, and theoretically we should be able to travel FTL due to the Lorentz factor and the time dilation we would experience. For day-to-day use, especially within Federation space, there are few risks involved with warp drives. The biggest flaw is the dependency on dilithium, but we have that on Earth with our fossil fuels. Warp speeds are fast enough to traverse space, but not too fast to make space feel small, as just travelling through Federation space would take hours, and Voyager had the impossible task of travelling over 70,000 light years, a journey that they thought would take around 75 plus years. So Star Trek definitely does space travel well. But we have a few more franchises to look at before we can say it's the best. So let me know your thoughts. Thanks very much for watching. I'll talk to you again very soon.